Now, did I... Oh, come on, where'd it go? Put the food away. Okay. Now, do you remember what I said about volt? So with a volt, if you have 1 volt between A and B, that means when you move 1 coulomb, you can do 1 joule of work. It can release 1 joule of work. Okay. So that means if you move Q coulombs, then you can do Q amount of work. And if it wasn't V volts, if it was V volts, why are you so late for this class? Why are you so late though? No, but that's terrible because you had 2 hours and 11 minutes. How are you late for this class? I can understand you being late for 9 o'clock, but how are you late for an 11 o'clock class? Like, what were you doing since 9 o'clock? Asleep?
No, I was in town.
You were in town? Where were you in town?
My dad was going to change the place and they had...
You're at the embassy?
Yeah.
So why didn't you email me that you were at the embassy?
I think I said like I don't know like because I can't come again.
But you know you're supposed to. Mo, sit down. Come on. Now, if it was Q charge and V voltage, how much work is done? QV. How are you late for class when you just had maths? Did you ask me if you could do that?
No, they were right.
You're 12 minutes late. And you were late for maths this morning. Now who's your tutor?
Mr. Stephen.
Yeah, so you were 10 minutes late for maths and you're 10 minutes late for physics. So you've been 20 minutes late for me in total. 10 minutes twice. Now sit down and you'll have to talk to your tutor about this because it's starting to become annoying now. Alright, so the work is QV. Right? Now, does anyone remember, I think we talked about power. Do you remember what power, the formula for power? It's work over time. Yes?
Yeah.
So I can divide this by time and I get power equals QV over T. Yeah, I won't remove the screen, okay? Does anyone remember the formula for Q? I had a formula for Q in the first lesson. Now before that, IT. So you have ITV over T, so you have IV. So that's a new formula for today. Well, maybe I told you before, I don't remember. But power equals IV. So for example, if you have 20 volts and it's a current of, let's say, 2 amps, how much power can you get from this? 40 watts. So, you know, that's like a light bulb, 40 watts. So I need you to write that formula down and then we'll have a look at the homework question. Yeah? Okay, can I do the homework question now? Yeah, so I have here from the homework, what is the EMF, what is the big R, what is the small R, what is the power. Okay, so I want EMF, big R, small R. Okay, I'll just quickly draw it again. Can I go down now? Okay, so help me draw this here. You have two batteries here, wasn't it? And where's the ammeter, at the top or the bottom? The bottom, down here? Oh no, is this a resistor here? No, it's the voltmeter, is it? The resistor's at the bottom. Ammeter here. Voltmeter here? Batteries here. And then the switch is down here. Yes, like this. Yeah, okay. When the switch is open, there's only the voltmeter on the battery. Okay? So, what does the voltmeter read? Voltmeter is, it says it's what was it, 8.38, was it? 8.3. This is part 1. So therefore, the battery voltage is 8.3. Now what do we want in part 2? Is the big resistance, isn't it? Yeah, okay, so part 2. Now this is closed. Now if you look at this voltmeter, I'm going to remove it, don't panic. And just to make it a bit clearer, it's like it's around this, isn't it? Because if I just put it here, it's the same thing. Yeah? Yes? Yeah? What's wrong, Joshua? Well, I just moved the voltmeter over the resistor, but it's exactly the same. All I've done was just skip this piece of the wire. But I mean, there was nothing in between except for a switch, which was now closed. I'm just drawing it like this to make it a little clearer. What is the voltage around the resistor in the question? What does it say? It's something like 7 point... Right, so you need to use Ohm's law. V equals I R, isn't it? Now, what's the V? 7.58. What's the I? And is that given? It's on the ammeter, it's 3, okay. So, that's no problem. What's R, please? What, sorry, say again? 2.53, okay. Yeah. What's wrong? Now, next, we want the small resistance, yeah? We have two formulas we could use for this circuit. We have, I think, what was it? E equals I over R plus R. And what was the other one I gave you? E equals V minus... Oh yeah, but I think I rewrote it with a minus in it. V equals E minus IR. Yeah, you're basically saying that this is the voltage loss here, the IR, yeah. Now, which formulas can we use? Let's have a look. Well, do I know the big E? Yes. Do I know the I? Yes. Yeah. Do I know the big R? Yes. And do I know the small R? No, but I could get it from this formula. Here, do I know the big V? The big V is the... Yeah, and I know this. So I could use both. Yeah. So, I don't know, which one did people use? Did anyone use this one? Most people use this one? Yeah. Okay. I mean, it's easier, isn't it? So, V is... I'm sorry, what was it? 7.58 equals 8.3 minus 3R. So 8.3 minus 7.58 over 3, That's equal to or. Okay, so what's that? 0.24. What's wrong? No. Okay, what was the next question asking? What's the power, is it? Okay, so what's our formula for power? Power equals IV.
Is that voltage of?
Well, I need to read the question carefully to see which voltage it is. Determine the power consumption in or when the switch is closed. So it's the voltage through or. Yeah. And the I is 3 and the voltage is 7.58. So when you multiply them, what do you get?
22.7.
Is that what they have as well here? Yeah, 22.7. Okay, same thing. And then the last thing is how much charge is moved in 2 minutes, yeah? So what's our formula for charge Q? So it's 3 multiply 120, because it's seconds. 360 coulombs. Is that it? Yeah. Okay. So that's it for that one, okay? So actually, I thought this was going to be more difficult because it was a section B question. Turns out, it's not too difficult. I should point out though, in the formula book, this is not in the book, but this one is. So this one is in the book, and this one's not in the book. So you should remember that one.
So, but it doesn't matter because
It didn't matter here, but I'm sure there is a question where it will matter. Yes. Here, no. Okay. 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 Let me see. I want to give you a small question to try. So write this one down, please. I'll draw the circuit for you. So you got your battery. And you got your small resistor. And here this is 12 volts, and then this is 0.05 ohms.
The resistor is in the battery.
Yeah, it's the internal resistance of the battery. Yeah. And it's connected to something that has a resistance of 3 ohms. So I don't know, this could be a light bulb or it could be a heater or whatever. Has 3 ohms resistance. Now, what I'd like you to do first for me is I want to know what is the current in this circuit. So you can imagine you connect here maybe an ammeter. I want to know what's the current. So do that for me, and then I'll give you another part. No. No, not that. What did you use for that?
E equals I over R squared.
I equals
E equals big I over small over big R plus small r.
that should have double check your calculations. Yeah. Nearly, not quite. Give it to me 2 decimal places, please. What is it? Are you sure?
It's 3.9.
3.93.
Yeah, I'm using the this one.
Or whichever. 3.93. The formula you probably should use here is this one. E equals I over R plus R.
That one didn't do
Huh?
that. That didn't do
It didn't?
that. No, it didn't.
Oh, sorry, I wrote this the wrong way. It's I equals E over R plus R.
Yes. Yeah.
Did I write it down wrong?
That's it.
Oh, sorry. Teacher bad. I wrote this backwards. Bad teacher. Bad teacher. All right. So I equals 12 over 305, which is 3.93 amps. Sorry, we want to make sure we get this right. All right. Now, there's a little bit of vocabulary I need to teach you. Does anyone know this one here? Terminal voltage.
Voltage when the switch is closed.
Not quite enough information in that.
Or voltage when the switch is open.
Does anyone know terminal voltage?
Yes, I know it's an expression.
Huh? What?
Going through system.
Let me tell you what terminal voltage is, okay? Now watch. Terminal voltage means you put a voltmeter around the battery. Now wait. Think very carefully. What way does the current move in this diagram? To the left or to the right? Left. Yeah? So the current goes this way. So this is the A and this is the B. Now be very careful. It's not telling me the voltage from A to B this way. It's telling me the voltage from A to B the long way. In other words, terminal voltage will tell me the voltage really in this. Yeah?
Oh, that's not a resistor.
That's a resistor here.
That's what I said.
Well, in this case, it's through the resistor. But terminal voltage means you put a voltmeter around the battery, but you can see really what that's doing in this example is it's telling you the voltage around the circuit. And there's only one thing in the circuit. What's that? The 3 ohm resistor. We don't really count the ammeter. Okay? So the 3 ohm resistor. So my question now to you is, tell me what the terminal voltage is. What is the terminal voltage here? Now, you have to use the other formula with the E in it. Okay? So you know the E. You want the V, the voltmeter V. You know the I. You now know the I, and you know the small r. So tell me what the terminal voltage here is. Yeah, it's the one using the loss and volts one. Yeah, so get the answer for me.
It's 11.8.
11.8 is correct. So what formula did you use, Tanish?
E equals to capital IR plus capital I small r. I mean, it's just rearranging.
V plus
Yeah.
I or. So you got, what was the E? 12, wasn't it?
Yeah.
Equals V plus 3 times 0.05. Yeah?
3.93 times 0.5.
Oh, sorry, 3.93, of course. No, yeah, 3.93 times 0.05. So what does the V work out as? 11.8 volts, yeah. Amps.
Isn't it point V?
No, the current is 3.93. Yeah, small resistance is 0.05. Yeah? Okay. Can I go down? Yeah. Okay.
So you don't use complete resistance when you find terminal voltage.
Well, we didn't need to, but V equals I or can someone type in 3 multiply 3.93 and what do you get?
What?
3 multiply 3. So 11.8.
Yeah.
So to answer your question, Joshua, you could have used Ohm's law, or V equals I or, which equals 3.93 multiply 3, which is also 11.8. So you could have used Ohm's law as well. That should not surprise you because those two formulas, I got them from Ohm's law, the proof.
Yeah, it's because it's V is capital IR.
Yeah. So there's nothing really too surprising, I guess. Okay, can I go to the next example now? Yeah? So we have, I'll draw this for you. Sorry, do you need to write this down? You got it? Are you sure? Okay. P equals IV. But, hey, come on, listen. The V, I sometimes don't know it.
So IR.
So we know the or sometimes.
So
Yeah.
IR.
So using Ohm's law, V equals I or, I can put that in. And I get P equals I squared or. So this is another formula for power. It's just substitution. So let me give you an example. Like, let's go back to this one. So what would be the power here? It would be I squared multiply 3. Can you tell me what that is here? I squared multiply 3.
46.3.
What is it?
46.33.
Okay. Watts. So maybe this resistor is like a light bulb. Light bulb is maybe 46 watts. You know? Anything else about 46 watts? TV will be about 46 watts. Okay, let me give you something which I remember in the exam. So we have a battery. It's similar to what we just did. Battery and small resistor.
This is like another question.
There's another question, yeah. And this here, you can change the resistance though. Variable resistor. Okay. And part one of the question is find P in the resistor in terms of E or and or, where this is E, this is small r, and I have this set to big R, but I can change it. But for the moment, it's big R. I'll give you a minute to try that. I want you to get me a formula for P. And you can use P equals IV, you can use P equals I squared R, you can use the two formulas I did yesterday. Try to put them together to give me a formula for P with E, R, and R in it. What's that? And yeah, you don't want current in your formula. So the current is I. You don't know what it is, so you need to try and remove that from your formula.
Well, you can have V.
No, just to be clear, the only things I want in the formula for power are those three things: E, R, and R. I'll do it in a minute. Well, I'll have a look, see what you got. Where's your answer for P? Nope, because I didn't say I wanted I in it, did I? Yeah. Yes, I think so. I'm not sure if you're missing another square. Should you have the additions? Yeah, it looked at something not quite right. Yeah, I think that's it now. I think that's it. Yeah. What's the letter is this?
E.
Yeah, so simplify this. That makes this.
This one.
Oh, sorry. What the heck is that? Oh, yeah, don't have the numerator. Don't give me this times or business. Yeah. Yep, that's it. Okay, so I have two people that have it. I have three people who have it. What's that? E? Nearly. Now, I don't want the I, okay? Anyone else? No? Okay, well, you think you got it? Come on. Oh, no. You know if you square this, it's not 4 squared plus 4 squared. Yes. Okay, let's do it now. So I'm happy to see a few people got it. So Ira, what did you start off with here? You did P equals IV, and we don't want I and we don't want V. So what formula did you use next?
I equals E over small.
Yeah, and you put that in there for I. So you end up with P equals EV over R plus R. Now we don't want the V. So what did you use?
V equals I.
Which R? Big or small? Big R. So that goes in there. So you get P equals E I. Is this right?
Yeah,
R over R plus R. Oh, we still have to do something about this I. So what's next now?
Same formula. I equals E over small.
So now this one goes in there. So you get E times E over R plus R over R plus R. Okay, so they make a square. So you get E squared R over R plus R squared. That's the formula for power. Now, part 2 of the question. You've got P and big R. By the way, in the exam they'll do more than 4 boxes. I'm only going to do 4. Yep. Sorry about that.
Is that 0.15 or
0.75. So the next part of the question is this. They tell you the internal resistance is 0.05. Oh, sorry, and I should also tell you the voltage of the battery. The voltage of the battery is 12. Now, if you go back to the question, what can you change in your circuit? What are you allowed to change? See the big resistance there, yeah? Can you change the small resistance? No. And the battery voltage? No. So what they want you to do is to work out the power for different values of resistance. How much power do you get? So I'll let you do that now. You have the formula for power, so I want the 4 different answers here. Okay, do you have those 4 numbers? All right. So what is the first number?
64.
64. Sorry, these are in watts and these are in ohms. 64.
72.
72.
69.
69.1. 69.1 and
64.
so if I was to make a graph here of power and resistance, it would go up, wouldn't it? And then come back down.
Why is that?
Well, it will start from 0.
Wouldn't it be if you put R as 0, you get P as 0? Yeah. Did you get those numbers?
Yep.
Now, this is an important result for electronics. Okay, so you remember that you have your battery and you have your variable resistor. This do that in a moment, or you made some mistake. Yes, you can do it in a moment. This is an important result for electronics. Is anyone doing electronic engineering? No? No? Okay. Anyway, it's still important. So, you have your battery and you have your resistor. But remember, your resistor is just like a heater, it's like a light bulb. It just uses energy. Yeah? Now, if you put in a small resistor, like a small light bulb, how much power do you get? 64 watts. And if you put in a big resistor, so like a big light bulb, how much power do you get? 64. So if you put in a medium-sized light bulb, how much power do you get? 72. So which light bulb would be the brightest? Which will have the most light? The medium one, wouldn't it? So this makes you think, you put in a small light bulb, it's not so bright. You put in a big light bulb, still it's not so bright. But if you put one in between, it's maximum brightness. So this means when you're making a circuit that's, like a light bulb or a radio or a TV or whatever that uses a battery, there's a perfect power. There's a maximum power. In this case, what is the maximum power you can get? 72. Now, what value of resistance do you need to get that?
0.5.
Now, does that number seem familiar? Where have we seen that number before? It's a small resistor, isn't it? And that's the result here. The maximum power you can get is when big or equals small or. And this is called matching the load. Because if I go back to my diagram here, this here is called the load. So when this matches this, this is when you get most maximum power. So when I saw this in the exam, it had two parts. That was part one, that was part two, and then part three is what's the maximum power. And the answer, you're supposed to get it from your graph. It is 72 watts is the maximum power.
Scroll down.
Yep, to there is. Oh, sorry, yeah. Got that? Yeah? Okay, so now we can go on to the next section. So today and yesterday we were talking a lot about batteries in a circuit and stuff like that. Okay, so now, next. It's very important. So important for the exam. This topic can sometimes be 20 marks in the exam, and it's really not very difficult. It's just you need to know the process, okay? It's a very, very, very important topic. Very important. It's called Kirchhoffs Rules. And Kirchhoff has two rules for circuits. And they're very useful rules that let you solve circuit problems. So he has two rules. And I'll explain how to use the rules now. So his first rule, rule 1, this is called the Junction Rule. And the rule says if you add all the current in a junction, it should equal 0. Now, I need to explain what that means with an example, but that's his first rule, junction rule. And rule 2 is called the loop rule. And it means if you add all the voltages around a loop, the total is also 0. That's great, Mr. Kirchhoff, but what does that mean for me in my life? So I'll do some examples now.
So could you explain the first rule?
Dude, what did I just say? I said I'll do some examples now so I can explain it. Okay. Can I go on to the example now? Yep. So let me draw my circuit. We have a battery of 6 volts, resistor of 8 ohms, another battery, so this is the resistance here, another battery of 12 volts again, and then another resistor here, but this one is 10 ohms. And it goes back here. And of course this is the minus and this is the plus. And the question is, find the current. Find the current in the circuit. Okay.
So is the battery with primary?
It sure is. It sure is. Yeah.
It's coming from positive.
Yeah, no, it's right. It's right. So what's going to happen here is the batteries aren't working together. They're working against each other.
So if this push current and that will be
It could. I think what will happen is the current will move down from the top battery. It will pass through this resistor 8, and then it'll get to the battery at the bottom. So I think the battery at the bottom will probably win out. I don't know. But
battery will be bigger.
oh, it is. Sorry. Oh, yes. The battery at the bottom will win out. Yeah. Okay. Now, a little bit of vocabulary. Junction is like a road junction where 2 pieces come together. This is called a junction. Does this have any junctions? No, it's just one loop, isn't it? It doesn't split or come together. So we don't use the junction rule. We use the loop rule. And the way you use the loop rule, are we all listening? The way to use the loop rule is you always start with a battery. It doesn't matter which battery, just pick a battery to start with. So we can pick the battery at the top or the battery at the bottom. In my experience is it's a little easier to start with the bigger battery. So I'll start with the bigger battery. Okay. What's the voltage in this battery? 12. And then what you do is you go around. What's the voltage here? You must use Ohm's law. What is Ohm's law for voltage? V equals IR. Now what happens in Kirchhoffs rule is you start off with 12 volts, but then you lose every time you go through a resistor. So how much do you lose here? You would lose minus 8I. Okay, so we're going through. Now we get to this next battery. No. Don't say anything until I ask you. I want you to think. Do you get or do you lose 6 volts? Now don't say it until I tell you to say it. So think first. Do you get or do you lose 6 volts? Don't say it. And just think about what I was saying about batteries last week. Okay. Are we ready? So do you get or lose 6 volts? Lose 6 volts. You lose 6 volts. So I need a minus 6. Okay? Now, when I get to this resistor, how much do I lose? 10I. Equal 0. This is what's called the loop rule. Now, you told me the I. Work out the I from this. You see, it's a very good rule because it's very easy to use and it, gives you the current. 0.3, is it? Yeah? Yeah, 0.3. Yes, go. Help me tell. How many people have seen Kirchhoffs rules before? This is a new topic for you, Tanish? Have you seen it before or it's new? It's new. It's new. But it's so useful. So useful. In the exam last year, Kirchhoffs rules were for, I think, like 15 marks. Okay? Now, there's more complicated circuits which we'll look at, but this is, the basic idea of his loop rule. Right, let's look at a more difficult one in a moment. Yeah, in a moment, yeah. So we'll do an example next where we need to use both rules, the loop rule and the junction rule. See, Paul was looking forward to Kirchhoffs rules, and now he's not in today. Do you remember last week he was saying he wants to go on to Kirchhoffs rules? Not here today. So when you see Tal tomorrow, you have to say, oh man, so much fun doing Kirchhoffs rules. Really missed a lot. Can I do the next example? Yeah, okay. So next circuit. Okay, so we have resistor, battery, and then resistor. And this here is 4 ohms, and this here is 2 ohms, and this here is 10 volts, and this one here is 14 volts. And the question is, we cannot simplify, what do we ask for? Oh yeah, find the currents. Find the current again. Okay, so I'll let you draw it and then I'll explain it.
Is that the voltage of the battery?
10 volt battery? Yes, 14 volt battery, a 4 ohm and a 2 ohm resistor. Can I do it now? Yeah. Okay. There's a current here. I'm going to call the current I1. Yes? You got that? And the current goes around here. But what happens when the current gets to this piece? It splits, doesn't it? And is it the same or is it different when it splits? Different. So this here is I2 and then this one here is I3.
But is the voltage the same?
The voltage is the same, but the current is different. Because some of the coulombs go left and some of the coulombs go right. Yes. Yeah. Okay, so this here is still I2 and then this one here is still I3. But then when it gets back to here, it goes back to I1 because we need it to be I1 when it gets back to the top. So in this question there are 3 currents. 3 currents. Okay. So that's what your diagram should look like. Now I know it might look complicated, but it's not that complicated. Can I start now with the formulas? So how many junctions do we have? Can somebody see, or can anyone see how many junctions we have? How many parts does it split? It splits twice, doesn't it? Once here and once here. So let's use the junction rule. So this is how the junction rule works. The current that goes into the junction is positive, and the current that leaves the junction is negative. On the left, what current is going into the junction? Into the junction. I1, 2, or 3. What's going into the junction?
I1.
I1 is going in. And then what's leaving the junction?
I1.
I2 and I3. So this is the junction rule. We say I1 minus I2 minus I3 equals 0. Now, another way to think about this, okay? How much current goes in? I1. And how much current goes out? I2 and I3. Which must also equal I1. Because what goes in must come out. So really, that's all that rule says. The current that goes in equals the current that goes out. If you just make it equal 0, you get that formula.
So
Now,
you have to just visualize the one side instead of the whole thing.
just look at the point exactly. Look at it.
It's just the one single line on the phone.
Not even the, yeah, just like that tiny little piece on the left.
Yeah, so what comes in and minus with what comes out.
Yeah, should equal 0. Now, let's look at the junction on the right. What equation do I get on the junction on the right? What's going in? Yeah, the I2 and I3. What's going out?
I1.
So the equation would be I2 plus I3 minus I1 equals 0. In fact, that is the same as that equation, isn't it? So we don't need to use the junction rule again because we get the same result. So I just use it once. Okay. Now I use the loop rule. Loop rule. Now what's nice about the loop rule is you can choose any loop. So, if I start at this battery, are we looking up? If I start at this battery, I can make one loop, or I can make a second loop if I go all the way around. It's any loop. So let's do the small loop first. Let's start here. What's the voltage here? 14. Minus, which I? I1. Now, here, gain or lose 10 volts? Gain. Plus 10. Equal, plus 10 equals 0. Okay. Now, let me use the loop rule again on the bigger loop. So the loop rule again. Oh, actually, I said there's 2 loops. There's actually 3 loops. There's another loop. We can actually use this one here. I think I'm going to choose this loop because it's smaller. It's easier. This loop here. So if I start here, I have 10, and I go around.
Why do you put like plus 10?
You start at a battery, and it's like that's how much you have at the beginning, and then you go around the loop, and then every time you hit something, you lose it. You know, so the battery is like how much you have at the start. So it's like you have 10 volts, and then every time you walk through something, you lose some of that voltage.
Why don't you start from 40 to 8?
No, you can. I realised that if I start at 10, I can make a smaller loop, which makes a smaller equation. It doesn't matter. You can still do it at 40.
Are we like making a bigger loop? Like
I was going to do that, but then I realised I can save some work by making a smaller loop.
so they're going this way.
I'm going, yes, I'm starting at 10 and I'm going this way now. Yeah. 10. And then when I hit this, what's next?
2 I2, I3.
2I3 plus or minus?
Minus.
Ah, you're all wrong. Plus. And then it goes back here and it equals 0. Now, why is it plus in this case?
That's going to be 1.
Yeah. One sec. When I move through that resistor, I am moving backwards. The current is going the other way. So I need to change the sign around. Yeah? How?
I don't understand that.
Listen carefully. When I go around clockwise and I move through the resistor, look, you need to picture your light walking around it, okay? So I start at 10 and I walk to the right, I walk down, and I walk left. When I walk left, notice how I'm walking against the current. The current is going this way,
Yeah.
whereas it should really be going with me. It's not wrong, it's not a problem, it just means because it's opposite of what's normal, I have a different sign. Just like with the battery. If I go through the battery, it's 10 volts, but if I turn the battery around the other way, what happens? Minus 10 volts. That's all that's happened, Tanish. When I go through the resistor, I lose resistance, or I lose voltage, yes? Unless it's turned around. Then I gain voltage, okay?
10 minus 2I.
Yeah, it's like minus, yeah.
Oh, yeah.
Yes, it is. Now, he had a good question, very good question. Could the current be negative? The answer is yes. If your current works out as negative, it just means on your diagram you drew it pointing the wrong way. And that is important, and that does come up in the exam. They would say something like, which way is the current moving? So you need to, if the current is positive, it means you drew it correctly. If the current is negative, it means you drew it the wrong way around. That's all. It's not a big thing. But you're right, good question. Now, Tanish, if I use, well, everybody here, if I use the big loop, what would be in my equation? What i's? I would have I1 and I3. Yeah.
What is minus?
I'd have 14 minus 4I1 minus 2I3
And
equals 0.
Oh, you already know I.
But look at my equation 3. It's much smaller, isn't it? I can get I3. And then if I know I3, how many equations do I have now? 2. And how many unknowns? No, 2. I1 and I2. Because I can get I3 here easily.
Exactly I1 easier.
Oh yeah, that's just I1, isn't it? So I can get I1. And then once I have I1 and I3, then I can get I2. So I want everybody to calculate I1, 2, and 3 for me now.
I1 is 6.
I1 is 6, is it?
Yeah.
Okay, you got I1 is 6. Let me write that down. I1 is
I think it's
6. I3 is
Minus
-5.
5.
And then I2, please. 11.
I3 is actually 5.
Minus 5.
No, -5. It is. Now, as you were saying, I is negative. Well, that just means, if you look at I3, is I3 going clockwise or anti-clockwise in my picture? It's going anti-clockwise, isn't it? But because my answer is negative, it means I drew it the wrong way. It's actually going the other direction, clockwise. So the question might be, which way is the current moving through the 2 ohm resistor? So which way is the current going? Left or right? Left. Okay, so the answer would be the current moves left through the 2 ohm resistor. But What's wrong?
How does the curve move left if it splits into two?
No, I'm just zoom in your mind. Just look at this and forget everything else. So on my diagram, which way is I3 moving in that circle?
Right.
Right. But my I3 is negative, which means I drew it backwards or it's going the other way. So it's not moving right, it's moving left.
So which way do we consider? We move the other way to count that we use.
What do you mean?
I mean, if it's negative because we counted clockwise,
Yeah.
while it counts anti-clockwise,
Yeah.
so it becomes negative 5 volts.
No, it just means that if I keep my diagram like this, my I is -5. If I did this question again and drew the arrow the other way, I would get +5.
Yeah.
A negative I just means you have the arrow pointing the wrong way. That's all. Now, which way does the current move? Left. And who can tell me which way the electrons move? Very good. The electrons move right. Because if you remember, the electrons always move in the opposite direction of the current. Always. Now, I want to give you one to try that's from an exam question. But what do you think? Kirchhoffs Rules, I think it's actually a very good topic for the exam if it comes up. It's straightforward. It's straightforward. So let's have a look if it came up in this year. Yes, it did. Okay. Yes. Now, in this, before you start this one, in this diagram, just be careful. You see that power supply? It's 9.25 volts and a small resistor of 0.42. So my advice is to draw this on your diagram as two things. A 9.25 volt power supply and a small 0.42 resistor. Okay, draw them as separate objects. Do you understand what I mean? No? Okay. Draw it like this. Right.
What's 2.68?
Hold on. Draw it like this, Mo. Battery here of 9.25 and then draw a small resistor here of 0.42 and then draw the rest of the diagram. Now what were you asking me, Joshua?
What's 2.68?
Oh, that's the current here. They give it to you.
It says determine current I. Oh, it's good.
Oh yeah, it's here, it splits I1, I2. So they've given you one of the currents. Okay. I would like everybody to do this one for me. Oh, and just be careful, this is a battery here, and you do not know its voltage. That's actually what they wanted the last part here. Okay, so can everyone try that for me? See what we get.
Third of voltage for the battery.
Oh, speaking of, I can see my battery's about to go. What's your question, Joshua? this.
Battery at bottom the old button.
Battery at the bottom, the positive, yeah, it's not very clear. The positive, it's going to the right. It's the negative and the positive like that. Yeah, that small line is the positive side, and that black box is the negative side of it, I think. Yeah. How the heck did this fall even when I put blue tack on it? How many loops are here? How many loops can you make? 3.
3, 4.
3 loops. And how many junctions? 2. Huh? There's 3 loops. Yeah, there's 3 loops though. We can loop around the outside, we can loop around the inside, and we can loop around the small loop at the bottom. So I'm just wondering if anyone's finished. Probably not. You are, yeah? Okay. Okay, we'll give it a couple more minutes. Do you want me to pop the answers up real quick and check? No, Mo, you're not finished. Right or wrong, Jess? Joshua? Right? All of them? Okay. What's for lunch? Huh? Chicken roll? But you bought it now knowing that you wouldn't be able to eat it for 2 hours. Huh? Yeah, but why not buy it after this class? Huh? So you figured, nuts to Stephen, I'll just miss a bit of his class. Okay, who else is finished? Anyone else finished now? Let's have a look. Okay. Do we have answers here soon? You have one answer, 2 answers, and you're doing the last one? Yeah. Dana? You seem like you're having trouble. You have trouble? Okay, let me have a look. Let me help you. So here, 9.25. Now, you tell me, which loop are you doing? What loop do you want? Here, actually, move the time to 7. Okay, that's right. You're right. Now, you're starting here, yes? Which way do you want to move? Tell me. Yeah, inside or outside? Inside? Okay, so you have 9.25. Okay, and it goes around here, and then it hits this battery. Does it add? Does it give you volts, or do you lose volts? What do you think? Sorry. Get. Because look, this is the positive, and this is the negative. And when you put batteries like this, they add together. So plus E. Plus E. Now, when you go here, you get or lose. You lose. You lose. What number is this? What number is that? 3. So how much volts do you lose? What's the formula for volts? V equals I or. Yeah, 3 I2. So minus. Yeah. 3 I2 or 2 I2? Is that 3? Yeah. Now we go here, and what happens? You lose. So minus 2 times 2.6. 5.2. And then here is minus 2.6 multiply. What is it? 2.6 multiply 0.42. What's that? 1.092 equals 0. Okay. Now let's do this loop together. So start with this battery, E.
3.067.
E. Yeah. Minus. Yeah.
How many decimal places is this?
Yeah. Yeah. And then here. Very good. 5 and 1 equals 0. Now, how many equations do you have? How many? 3. Yeah? 1, 2, 3. How many things do you not know? What do you not know? You do not know I1. You don't know. And something else you don't know. E. You have 3 equations, 3 things you don't know, so you can solve this. So I think maybe, you see the E here? You can substitute this in here for E. Then you have I1, I2, I1, I2, and you can solve. Is that the answers? So what do you think? Have you done this before, or is this a new topic? New topic. It's okay, isn't it?
Yeah, but so much more.
It's great. I really, really like this in the exam. When you get it in the exam, it should be a boost to your marks. It should be, okay? Now I'll give you one more to do, and then we'll finish, okay? So I'll try and find one that's a little bit bigger than that. That's very dramatic, Tavish. I'll just flash the answers up here quick. I think a lot of people got it though. I1 was 0.592. Did you get that, Joshua? Yeah. And then I2 is 2.01. So, Ira, you got that one, did you? And then, Soon, did you get 3.07 for E? Yeah. Okay, great. So, let's open up another year. Close, and exit, and open. Here we go. Okay. Dropbox, NCUK, past papers, physics. Let's go 2012.
Does it come every year?
No, doesn't come up every year, but there's a good chance of it coming up. Like, it is a popular question. So you can see it came up in 2013, and
What's that?
there you go.
What's the one on top?
It's also Kirchhoff. So part 1 mark, the EMF. Now part 2 is Kirchhoff. But, I mean, you could use Kirchhoff, but you don't need to. But you could, except they don't want the I. What they want is the voltage here. Okay? And here is 10 volts. So if you did a loop, for example, it would be 10, yes? And then here you have to do an I1, and then this is an I2 and an I3. So it'd be 10 minus 10I2 minus 60 I1 equals 0. Then here we have 10 minus 40 I2 minus 60 I1. Yeah. Sorry. 10 minus 40 I3 minus 60 I1 equals 0. And we shouldn't really do a loop here because there's no battery. And remember I said it's always good to have a battery to start with. My advice. So how many equations do we have? 2. But how many unknowns? 3. I1, I2, and I3. So we need one more equation. What could I use? Junction rule. I1 minus I2 minus I3 equals 0. So can you find I1, I2, I3? Yes. Now here they want the voltage. So I can use Ohm's law. What's Ohm's law? V equals IR. What's the R? 60. And what's the I? We have to find which I? I1. And multiply it. So
So you have to use Kirchhoff for this?
No, you don't. I'm just saying Kirchhoff is very flexible. You can use it for a lot of circuits. In fact, you can use it for all circuits.
But how would you find that without Kirchhoff?
Without Kirchhoff, you would have to add these resistors together, and then add this resistor together, and then use Ohm's law, to get the current. Then once you have the current, you could use Ohm's law again. I'm just saying, whichever is the easiest way for you is to use it. Personally, I really, really like Kirchhoffs rules, because for me, they make it a very straightforward process. You know what I mean? Like a very automatic way to do it. Do you get what I'm saying by that? Yeah. So you could use Kirchhoff here, and they tell you to use Kirchhoff here. Wait, I didn't tell you what to do yet. So I would like you for the last 10 minutes to do this one Kirchhoff question. Again, it is 10 marks. So it's 10% of the exam. And they give you the voltages and the resistors and they're looking for the currents. And try to make small loops.
How come IT is going in the opposite direction?
It's because the bacteria is
Oh.
The battery on the left. What do you mean I2 is going in the opposite direction?
It's going in the opposite direction.
Well, it's going in the right direction from the 4.
No, 2
No, but you see the I2 at the top is going to the left, yeah?
Yeah.
That's coming from the 4-volt battery. And then on the left, there's a 50-volt battery and it's sending an I1 to the right.
Yeah, but the current splits into 2. I1 splits into 2.
True. So it's very likely that the I1 will be bigger than the I2, and therefore the I2 answer will probably be negative. It'll probably be dominated and pushed away by the I1. But Joshua, it doesn't actually matter. If you drew it backwards, you'll just get a different sign in the answer. But because they gave me that diagram, I need to use that one in my equations. How many loops can you make?
2.
1, 2, 3. 3 loops. I would use the loop on the left and the loop on the right. Maybe the big loop. I don't know if it's helpful. Yeah. You want to check the answer?
No, I just want to check. Yeah.
Yeah. Okay. Let's have a look here. Which number? Okay. Oh, come on. I1 is there. I2 is there. I3 is there. Did you get them? I2 is negative. Didn't get the I3, okay. For which eye? Did you get it? No. Probably a small mistake somewhere, don't worry. I want to show you something, and you can finish that at home, okay? You have the answer on Moodle if you need it, alright? I want to show you something now. Last time, I think I was saying it to Tanish and to Soon. I told you last time something about if you have a battery with a small, if you have a battery here, Alright, let me just draw it with battery. And it's connected to the voltmeter like this. Then the V on the voltmeter will equal the battery voltage. And that's true. And when I said it, I didn't like saying it because I felt like I was not considering the resistance inside the battery. But it's okay, because I can use Kirchhoffs rules to show you that this is true, V equals E, which I'll do now. So if I draw my battery, here it is here, with a small resistance R, and I have it connected to the voltmeter, and I'll put my battery in a little box. If I use Kirchhoffs rule and start here at E, I have E, and I go around, but the voltmeter doesn't really do anything, it's just to measure voltage. So in fact, let's imagine that there's no voltmeter, it's just like this. Okay. So if I use Kirchhoffs rule, what formula do I get if I use his loop rule? If I use his loop rule, what do I get? Can anyone say? E minus IR equal 0. So I get E equals IR. Now let me connect my voltmeter. So if I put my voltmeter here, it's measuring from here around to here. So, well, I don't even have to use my voltmeter. You know from Ohm's law, what does IR equal? V. It's going to be this V here. So I don't even know what to say. It's just what I was saying to you yet last time and here. That when there's nothing, now that's important though, when there's nothing in the circuit, when it's just the battery and the voltmeter, and that's it, then yes, the voltage is equal to E, the battery voltage. Okay? It's just I felt bad saying it to you and to you, Tanish, because I felt like I should have said or considered the small resistance in the battery, but it's not necessary here. And I hope with Kirchhoffs rule it's clear why. It's okay for you, Tanish? You sure?
Yes.
Okay, great. Alright.
Can I see your question?
Yeah. What I'll do is I'll put the answer up so you can check, and then I want to give you some homework. No, don't. You know this makes your teacher angry. Don't do this. He doesn't like the sound of the class shutting down before it's finished, okay? So the answer for those people who need it soon. Did you get them right or wrong? All of them? Oh, good job. 10 marks for this part, and then for the previous part it was 3 marks. Wait, yeah? Maybe we'll talk more about this next time, okay? But you have to, I think you have to consider the minus as well. Fix the direction. Oh, you want the answer for the direction? Sorry, yeah. The electrons flow through the 4-volt source. Okay. So the electrons flow through the 4-volt source. What? The electrons flow through the 4-volt source will be from its negative terminal. That's almost a sentence. Will be from its negative terminal to the positive. So the electrons go from negative to positive on the diagram. Let me just go. So that Kirchhoff was, look up, that Kirchhoff was 10 marks. The previous circuit was 3 marks. So that's 13 marks. But look at this. there was another circuit question here. And you can also use Kirchhoff for this circuit question. How many marks? For 6 marks. So for that question, 1 mark for a definition and 19 marks for circuits, where you can use Kirchhoff. So you have 20% there of the exam. 20% which you learned how to do really in this class today using Kirchhoffs Rules. So it's a great question, and it's important that you practice the diagrams, because part of the problem is the plus and the minus, with the batteries and the resistors. Okay, so I'm going to give you some homework to do, but I think what I'll do is I'll make tomorrow's class a tutorial class on the circuit diagrams, because I feel it deserves to get a tutorial class. So I'll tell you which ones to do, and then which ones to do tonight. So for homework and tomorrow's class, if you go to page 69, give me a pen here, I'll mark the book.
No, that's
Okay. Are you on page 69? Okay, so mark these questions. 21, 23, 25, 27, 29, 31. Yes.
Then tomorrow.
So 1, 2, 3, 4, 5. 6, is there? 1, 2, 3, 4, 5, 6, yeah. So what I want you to do for tonight is listen. Finish this question if it's not finished, and do the first question from that list. Then first. I feel kind today. And then tomorrow in the tutorial class, we'll work on the rest of those questions. What you can do is you can do it in class, and then I can do it on the board. Okay? But if you want to do more tonight, I have no problem with this. It will not upset me. In fact, if you did them all tonight, it might even make me happy. But I want you to do at least the first one and to finish that for homework, that question. Now wait, when I say finish, I mean the whole question. The part A and B that I didn't do as well. Now I'm not so kind. So I want the whole question 5 done. So this is year 2012, version 1, question 5. The whole question. I tell you what, I will be kind. Just finish that. You don't need to do the book question, okay? So just finish that, and we can do the book questions tomorrow in the class. I'm too kind. I know, I'm too kind.